Hello everyone. My name is Alumpri Kolni and I'm a student from Mizoram University studying MBA second semester. So today in this video, we are going to learn about sampling under research methodology. Let us first define what is sampling. Sampling is defined as the process of selecting certain members or a subset of the population to make statistical inferences from them and to estimate characteristics of the whole population. So, it is the process of choosing a representative portion of the entire population, an integral part of research methodology, and also it involves selecting a group of people, events, behaviors, or other elements with which to conduct a study. Sampling theory. It is developed to determine mathematically the most effective way to acquire a sample that would accurately reflect the population under study. Now moving on to key concepts of sampling theory, the first one is sample size. The number of individuals in our sample depends on the size of the population and on how precisely we want the results to represent the population as a whole. We can use a sample size calculator to determine how big our sample should be. In general, the larger the sample size, the more accurately and confidently we can make inferences about the whole population. The next one is sampling frame. The sampling frame is the actual list of individuals that the sample will be drawn from. Ideally, it should include the entire target population and nobody who is not part of the population. For example, we are doing research on working conditions at company X. Our population is all 1,000 employees of the company. Our sampling frame is the company's HR database, which lists the names and context details of every employee. Types of sampling techniques. There are two types, probability sampling and non-probability sampling. Probability sampling involves random selection, allowing us to make statistical inferences about the whole group, and non-probability sampling involves non-random selection based on convenience or other criteria, allowing us to easily collect initial data. Sampling techniques. Sampling techniques consist of two types, probability and non-probability, which will be further explained in the video. Probability sampling methods. Probability sampling means that every member of the population has a chance of being selected. If you want to produce results that are representative of the whole population, you need to use a probability sampling technique. From the table, we can see that there are four types of probability sample, which are simple random sample, systematic sample, stratified sample, and cluster sample. Simple random sampling. In a simple random sample, every member of the population has an equal chance of being selected. Our sampling frame should include the whole population. To conduct this type of sampling, we can use tools like random number generators or other techniques that are based entirely on chance. For example, I want to select a simple random sample of 100 employees of company X. I assign a number to every employee in the company database from 1 to 1000 and use a random number generator to select 100 numbers. Systematic sampling. Systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. Every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. For example, all employees of the company are listed in alphabetical order. From the first 10 numbers, we randomly select a starting point, number 6. From number 6 onwards, every 10th person on the list is selected, like 6, 16, 26, 36, and so on, and we end up with a sample of 100 people. Stratified sampling. This sampling method is appropriate when the population has mixed characteristics and you want to ensure that every characteristic is proportionally represented in the sample. We can divide the population into subgroups called strata based on the relevant characteristics, for example, gender, age range, income bracket, and job role. For example, the company has 800 female employees and 200 male employees. So, you want to ensure that the sample reflects the gender balance of the company. So, you sort the population into two strata based on gender. Then you can use random sampling on each other, selecting 80 women and 20 men, which gives you a representative sample of 100 people. Clustered sampling. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. If it is practically possible, we might include every individual from each sampled cluster. If the clusters themselves are large, we can also sample individuals from within each cluster using one of the techniques above. This method is good for dealing with large and dispersed populations, but there is more risk of error in the sample, as there could be substantial differences between clusters. It's difficult to guarantee that the sampled clusters are really representative of the whole population. Now moving on to non-probability sampling. In a non-probability sample, individuals are selected based on non-random criteria and not every individual has a chance of being included. This type of sample is easier and cheaper to access, but you can't use it to make valid statistical inferences about the whole population. Non-probability sampling techniques are often appropriate for exploratory and qualitative research. In this type of research, the aim is not to test a hypothesis about a broad population, but to develop an initial understanding of a small or under-researched population. Here are the four types of non-probability sampling. They are convenience sample, voluntary response sample, purposive sample, and snowball sample. Convenience sampling. A convenience sample simply includes the individual who happen to be the most accessible to the researcher. This is an easy and inexpensive way to gather initial data, but there is no way to tell if the sample is representative of the population, so it can't produce generalizable results. For example, we are researching opinions about student support services in our university, so after each of our classes, we ask our fellow students to complete a survey on the topic. This is a convenient way to gather data, but as we only surveyed students taking the same classes as us at the same level, the sample is not representative of all students of our university. The next one is voluntary response sampling. Similar to a convenience sample, a voluntary response sample is mainly based on ease of access. Instead of the researcher choosing participants and directly contacting them, people volunteer themselves. Example, by responding to public online survey. Voluntary response samples are always at least somewhat biased, as some people will inherently be more likely to volunteer than others. Snowball sampling. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. The number of people you have access to snowballs as you get in contact with more people. Purposive sampling. This type of sampling involves the researcher using their judgment to select a sample that is most useful to the purposes of the research. It is often used in qualitative research where the researcher wants to gain detailed knowledge about a specific phenomenon rather than make statistical inferences. An effective purposive sample must have clear criteria and rationale for inclusion. Here we can see the advantages of sampling. Number one is less workload. Number two is less resources. And the last one is gives result with known accuracy that can be calculated mathematically. That's all for today. Thank you for watching.